we move to the next paper, paper number 10 or presentation number 10, and paper ID is HEOP 1919, and the title is Removal of Impurities from Medical Waste Pyroelectric Char by Molten Salt Thermal Treatment. And the speaker is Muhammad+Usman. I request Muhammad to share the presentation and start the video. And please note that you have 15 minutes. Thank you.
Good evening, everybody. My name is Muhammad+Usman, and I am doing masters at Hosong University of Science and Technology in New Energy Science and Engineering at China Europe Institute of Clean and Renewable Energy. I am doing my research under the supervision of Professor Aijun Lee, and my research interests are solid waste disposal and technology assessment. And my professor is working on solid waste disposal, energy conservation, and life cycle assessment. So the presentation topic is removal of impurities from medical waste pyrolytic jar by molten salt thermal treatment. So if we look at the medical waste generation from 2011 to 2020, medical waste generation is growing yearly by year, but in 2020, there was more than 20% generation of medical waste as 2020 was the epidemic year, and due to COVID, there was a lot of generation of medical waste. So during the epidemic situation, disposal and collection of medical waste was a big problem. So if we look at the medical waste constitutes, like it consists of majorly on plastic, biomass, and rubber. And medical waste have very high calorific value, and it is maybe nearly equal to the gasoline fuel. So if we recover energy from the medical waste, this is a very valuable research and very valuable process. So if if we look at the problem faced by direct mixing of domestic waste with medical waste, as a first problem is faced by medical transportation. As a medical waste transportation is a very difficult because it is hygienic and it is infectious. So a lot of care is needed for the transportation of medical waste. So if we burn medical waste in the incinerator with the municipal solid waste, as a medical waste contain high amount of chlorine and it have also high calorific value. So due to this, it can cause emission of dioxin and furans, and also this can lead to of heavy metals in the ash that are also dangerous, and this also lead to the great corrosion and the heating surface corrosion. So there are many techniques that are used for the disposal of medical waste, like landfill sterilization, incineration, microwave sterilization, and pyrolysis and gasification. Each technique has its own benefit, but there are some limitations. So we cannot utilize a single technique for the disposal of medical waste. So if we look at the national policy of the China, so medical waste disposal system is mainly based on incineration, supplemented by centralized disposal. So, Ecology and Environmental Ministry of China suggests that the ministry encourage for the medical waste disposal facilities near the domestic waste facilities, centralized domestic waste disposal facilities to dispose and disinfect medical waste. So, if we combine two technologies, so we can achieve good results. So, we have combining pyrolysis and incineration for the disposal of medical waste. As we know that medical waste consists of high chlorine, it have high calorific value, high moisture, and it is also hazard. So if we go for the pyrolysis, so it can disinfect the medical waste and also it can produce energy product like pyrolysis oil, gas, and char. As it has high value of chlorine, 85% of the chlorine is evaporated at 480 degrees centigrade. And we are utilizing temperature between 400 and 600 degrees centigrade. And we have a valuable product as a solar residue char that also contain impurities. So if we uh, improve the quality of the char, we can directly burn this char in the domestic waste incinerator. So the problem associated with char, like char contain high content of salt of calcium, potassium, sodium, sulfur, and chlorine, and also contain heavy metals like zinc and tin. So these impurities in combustion create ash and pollutant. So this can cause increasing of fly ash, equipment corrosion, and pollution emissions. So here are the scientific problem. Like firstly, we will analyze the impurities in medical waste pyrolytic jar, and then we will study the impurity removal of medical waste pyrolytic char. For the analysis, we will determine the material and substances present in the char residue after the pyrolysis process that are harmful. So, for the impurity removal, we will study the molten salt thermal treatment on impurity removal of medical waste pyrolytic char. Firstly, we will discuss the first section, analysis of impurity in medical waste pyrolytic char. So, we are utilizing pyrolysis test bench that is consist on a nitrogen cylinder, gas flow meter, and a horizontal furnace. So we have utilized 500 milliliter per minute gas flow in this for the creating inert atmosphere, and we have set our furnace temperature at 500 degrees centigrade for the maximum chlorine removal, and we are utilizing 5 to 6 gram of sample. And the raw material that we are using are infusion tube that is plastic content, and the medical gas that is biomass content in the medical waste, and nitrile gloves as the rubber content. And as according to literature, we have also achieved the same result, like average recovery rate of the char was 15%. So for the analysis of the char, firstly we go for ultimate analysis where we determine the elements present in the char. Then we will go for proximate analysis where we determine moisture, ash, and volatile content and fixed carbon in the char. Then we go for XRF to determine all elements that are present in the char. Then we will go for XRD. There we determine the crystalline and phase structure of the impurities in the char. So we have also prepared the low temperature ash in the char where we burned the char at 390 degrees centigrade for 96 hours, and we have prepared the low temperature ash. And we have go for the XRF analysis of the ash. Then we will go for the XRD. In our XRF, we have determined the elements, and in XRD, we have determined the crystalline components. So if we go for the ultimate and proximate analysis of our raw material, here we found that our uh, infusion tube, gas, and nitrile gloves have high content of volatile matter, and they have also contain high carbon content. Like nitrile gloves contain 75% of carbon, and the most of the chlorine that is present is from infusion tube. So then we will go for the ultimate analysis of our char. Here we determine the fixed carbon that is 83%, and ash is in a very limited amount that is 2.5%, and it has volatile content of 14.34%. Like if we look at the ultimate analysis, our char is enriched in carbon. It contains 84% of the carbon, and it contains 3.31% of the hydrogen. Almost 95% of the ultimate analysis contents are non-hazard to the environment. So here are the XRF and XRD analysis of our materials or and char that we have done. In XRF analysis, we have determined that our char contain 91% of carbon, and it contains zinc, calcium, and tin in a large amount. And we have a wide range of impurities, but they are in minute amount. And our impurities are mainly from nitrile gloves. So here we can see that the impurities are from nitrile gloves, and the nitrile gloves have very limited carbon content. And if look at the chart from the infusion tube, it contains almost 99% carbon. So here we go for the XRD result uh, for our chart. Here we determine that the most of the impurities are from the nitrile gloves that are tin oxide, zinc sulfide, and calcium carbonate. And if we look at our mixed char, here are the most of the impurities that are detected that are tin oxide. So from the XRD result, it is clear that impurities are mainly from nitrile gloves. So here are the XRF analysis of our char. In the XRF analysis, we have determined that our ash contain calcium, zinc, and tin in a large amount. So the main significant amount of heavy metals in the ash are calcium, zinc, and tin. And other elements are like calcium, potassium, silicon, sulfur, and potassium. These are in less amount. So in this section, we will discuss the study of impurity removal from medical waste pyrolytic char. So here we are utilizing molten salt thermal treatment. So why we are utilizing molten salt thermal treatment? Because molten salt can dissolve both organic and inorganic compounds. Their reaction are very fast. Their mass transfer and thermal conductivity is high. They in molten salt a lot of reaction take place like acid wet reaction, exchange reaction, and solvation reaction. And for the removal of salt, molten carbonates are the good options. So here we have discussed like we are going for the simulation of the impurities for with the different type of molten salts. We are utilizing sodium nitrate, potassium nitrate salt, and then a combination of sodium nitrate, potassium nitrate, and sodium nitrite salt, and another combination of lithium carbonate, sodium carbonate, and potassium carbonate salt, and another salt of sodium hydroxide and sodium carbonate. So firstly, we go for the study for the impurity removal with sodium nitrite and potassium nitrite. So here we see that tin tin oxide doesn't reactivity with the molten salt. As we are utilizing in the simulation, we are utilizing 10:1 of molten salt. If we look for the calcium carbonate, it shows reactivity, but at very high temperature, at more than 400 degrees centigrade, and it is converted into CaO and CO2. So for the zinc sulfate, it shows very good reactivity in the molten salt system of sodium nitrate and potassium nitrate. But this molten salt system is not good for tin oxide and calcium carbonate removal. So in our next molten salt system, here sodium nitrate, potassium nitrate, and sodium nitrite. Here we can see that good reactivity for the tin oxide as it is converted into K2TiO3. But CO3 shows same behavior as the previous one. It shows reactivity but at very high temperature. And zinc sulfate shows very good reactivity in the molten salt system. But this molten salt system is again not good for the calcium carbonate removal. So our next molten salt system is lithium carbonate, sodium carbonate, and potassium carbonate. In this molten salt system, there is very good reactivity for the tin removal and very limited reactivity for the calcium carbonate as it reacts at very high temperature. But zinc sulfate shows limited reactivity and the reactivity is at very high temperature. So our next molten salt system is sodium hydroxide and sodium carbonate. This system shows a very good result for the removal of tin oxide, calcium carbonate, and zinc sulfate, as all the impurities are removed by this molten salt system. So this molten salt system is very good for the removal of all impurities from the periodic chart. So we have done our work till simulation, and in our future work, we will go for the thermal treatment of the molten salt in the experimental phase. Then we will go for pickling and washing for the after the molten salt thermal treatment. Then we will test the recovery rate of char. Then we will go for the elemental analysis and XRD and XRF molten salt of molten salt and char both. Then we will analyze the combustion characteristic analysis of the char, and we will compare these combustion characteristics analysis of the char with coal, as we have a research plan to use this as a coal as a substitute of coal. So this is our experimental bench that we will utilize for the molten salt thermal treatment. This is same like the previous one. So for our molten salt thermal treatment, we are utilizing sodium hydroxide and sodium carbonate as they shows very good reactivity for the impurity removal from the char. And we will utilize different temperatures, 350 to 500 degrees centigrade, and our reaction time will be 0.5 to 4 hour. And we will use fixed ratio of molten salt to char ratio 10:1 as in the previous literatures, most of the molten salt showed very good reactivity at 10:1. And we will determine our best result at time and temperature. So, for the conclusion of my presentation, medical waste periodic chart contain a wide range of purities as we seen in the XRF analysis. So the periodic chart contains elements zinc, calcium, and tin in large amount, and these elements are mainly in the form of tin oxide, zinc sulfate, and calcium carbonate. So the molten salt thermal treatment of sodium hydroxide and sodium carbonate shows a good reactivity for the impurity removal of the char. So, my research is basically on a project research on low temperature cascade pyrolysis mechanism of medical waste pyrolysis based on incineration and secondary reaction enhancement. And this project is funded by National Science Foundation of China. So, any question? Thanks for your attention.
Thank you, Muhammad, for giving presentation related to the impurities, how we have to remove. from medical waste, and especially then when we are using them for the combustion purpose, and especially you mentioned that molten salt thermal treatment also. So it's a very interesting work. And I have one simple question that you mentioned that the calorific value is also going to increase, right? So how do you think about from, or what is your opinion from that point of view?
Yes, we can, as the medical waste is enriching calorific value and the char created from this have high carbon content. So definitely we will achieve high calorific value, maybe near to the coal.
Very good. And then I have another very simple question regarding the emissions. You mentioned about the dioxins also, right?
Yes, yes.
So what do
As
you think, like, because how harmful they are for the health?
uh, dioxin and furones are very harmful to the health. So we are utilizing pyrolysis. This system chlorine is mostly removal in the pyrolysis aisle. So we will treat the pyrolysis aisle for the removal of chlorine, and then this pyrolysis aisle and gas will be used for the incineration again. So we
Yeah,
can
because
avoid.
calorific value is important, but we have to take care of the health also. No? So that is very
Yes,
important to remove this
yes,
dioxins and any other emissions which are going to help impact our health also. Okay, so that should be on top priority. Thank you. So thank you very
thank
much
you.
for your presentation in HERM.